Hello all, welcome to another session of team teaching, and our topic is chemical bonding. Our team consists of 3 members. I myself, Aswathy.A.
I'm Anatte V Chacko.
I'm Archana Sudevan.
Okay. Today we are dealing with the topic chemical bonding. We know that two metals or two atoms or two molecules are bonded together. Bonds, forces that hold groups of atoms together and make them function as a unit. Bond is a force. There are two types of bonds, ionic bonds and covalent bonds. In ionic bond, there's a transfer of electrons occur. In covalent bonding, there is sharing of electrons occur. We know that when an atom is stable, when it has 8 electrons in its outermost shell. Here we are having an example, sodium. Sodium's outermost shell consists of 1 electron. And chlorine is having 7 electrons. Sodium attains its stability by losing 1 electron to chlorine, and chlorine attains stability by accepting 1 electron from sodium. Thus, sodium plus ion and chlorine negative ions form. This is the formation of NaCl crystal.
So now we can detailedly see how sodium chloride is being formed. In sodium, we have 1 valence electron, whereas in chlorine, we have 7 valence electrons. So valence electrons are the electrons which are present in the outermost shell of an atom. And when we are going to the subshell electronic configuration of sodium, it is 1s2, 2s2, 2p6, and 3s1. Whereas chlorine, it is 1s2, 2s2, 2p6, 3s2, and 3p5. So if we remove one of the electron from the sodium and transfer to the chlorine, what happens? Yes, sodium will be attaining Na plus, whereas Cl minus will be formed in the case of chlorine by accepting 1 electron from sodium. So thereby an ionic bond will be formed. So now we can see how an ionic bond is formed. Next slide. Yes, that is Na plus will be exerting some sort of attraction to the Cl minus, which is the electrostatic force of attraction. And thereby the net charge in the compound must be equal to 0. So this is how sodium chloride is being formed.
And now in the table, you can see that the cations and monoatomic cations and their names. And these are the list of monoatomic cations having a plus charge. H plus hydrogen ion, Li plus lithium, like K plus potassium, Na plus sodium. And next slide. F minus fluoride, Cl minus chloride, Br minus bromide, and so on. These are the examples of monoatomic cations. And properties of ionic compounds. And all the ionic compounds having a crystalline structure. They're all crystalline solids, having high melting point, generally high boiling point, and excellent conductors of current, and they are generally soluble in water. Next slide. And here you can see the structure of sodium chloride or NaCl crystal lattice. Ionic compound from solid at ordinary temperatures. Ionic compounds organize in a characteristic crystal lattice of alternating positive and negative ions.
We have seen first that there is two types of bonding, that is ionic bonding and covalent bonding. There's another kind of bonding is there, that is metallic bonding. The chemical bonding that results from the attraction between metal atoms and the surrounding sea of electrons. That is metallic bonding. Vacant p and p orbitals in metals, outer energy levels overlap and allow outer electrons to move freely throughout the metal. Valence electrons do not belong to any one atom. We have seen the rule for bonding before.
Okay, so now we can see about the octet rule and its comments. That is the second row elements, especially carbon, nitrogen, oxygen, and fluorine, they all observe the octet rule configuration. And the second row elements, including boron and beryllium, often have fewer than the 8 electrons themselves, and they have very reactivity, highly reactive. And coming to the third row, they are heavier elements, that is, they can exceed the octet rule by using the empty valence d orbitals. And when writing the Lewis structure, they satisfy the octet first and then place the electrons around the elements having available the d orbitals. So now we can move on to the Lewis structure. Here you can see the Lewis structure of CCl4 molecule. It is the carbon tetrachloride. Okay, so here the valence electrons are arranged among the atoms in a molecule, and it actually reflects the idea that is the stability of a compound relates to the noble gas electronic configuration. And when we are completing a Lewis structure of CH3Cl, first of all, what we need to do is that make carbon the central atom. Okay, then we need to add up the available valence electrons. That is, for carbon, we have 4 electrons, and for each hydrogen, we have 1 electron. Thereby, in total, 3 hydrogens will be having 3 electrons. And finally, the chlorine atom will be having 7 electrons. And that comes a total of 40 electrons. Then what we need to do is that we need to join the peripheral atoms towards the central atom. Okay, with these electron pairs and complete the octets in the atom other than the hydrogen with remaining electrons. That is, 8 electrons should be completed. Next slide. Yes. So here you can see how multiple covalent bonds are being formed. That is, in order to form a double bond, 2 pairs of electrons must be shared. Okay. And next slide, we can see that in order to form a triple bond, example ethylene or acetylene, there is a sharing of 3 pairs of electrons. Okay. So
now hydrogen bonding. Bonding between hydrogen and more electronegative neighboring atoms such as oxygen and nitrogen. Here you can see in the figure, hydrogen bonded sheet. Hydrogen bonding in Kevlar, a strong polymer used in bulletproof vest. It is an application of hydrogen bonding, and hydrogen bonding in water can be seen in the figure where you can see that the hydrogen bonding is maintained there. And in the next slide, you can go to the follow-up review questions. So define octet rule, and you have studied octet rule. I think you can answer this. Explain octet rule in ionic compounds. Here we have discussed the octet rule in ionic compounds as well as covalent compounds. And the third question is briefly explain hydrogen bonding with an example. That's all.
Here you are having follow-up activity.